All right, number 35. And so number 35 takes a look at the function 1 over root x. But our instructions are the same. We're still looking for an equation of the line that is tangent to our graph, or to our graph of 1 over root x, and is parallel to this line. And so, because it's parallel, our slope for the parallel is the same. Okay, and so we need to find the derivative of the square root of x. Now this one's going to be a little bit tougher as far as using the limit to find it, but it's still quite doable. Okay, so let's go ahead and formally define it. Our derivative is defined as the limit as delta x tends to 0 of f of x plus delta x minus f of x all over delta x. Okay, so that means that our derivative is equal to the limit as delta x tends to 0 of f, or I'm sorry, 1 over root x plus delta x minus 1 over the root of x all over delta x. That's just using substitution. In order to do the subtraction up top, we have to have a common denominator. And so I'm going to get a common denominator, and the common denominator will, I'm going to multiply this one by root x on top and bottom. I'm going to multiply this one by root x plus delta x on top and bottom. And then I'll have a common denominator of root x, root delta plus, or x plus delta x. And so this one is going to be square root of x minus square root of x plus delta x all over the square root of x times the square root of x plus delta x. And that's still all over our change of x, and that's the limit as delta x tends to 0. All right, here we're going to need to use the conjugate, and that's to clear these roots up at the top. I need to multiply both top and bottom by the conjugate of the numerator. This is to rationalize the numerator. Okay, so I'm going to multiply by root x plus delta x on top and bottom, x plus delta x. Okay, and when I do that, get the limit as delta x tends to 0 of, and now the sum and difference, the conjugates produce the difference of two squares. If I square the root, it cancels the root, and so I get x minus. And then I get, the root cancels, I get what's underneath, x plus delta x, all over the root of x times the root of x plus delta x times root x plus root, x plus delta x. X plus delta x. All of that over delta x. That delta x on the bottom is still left over from the formal definition. Okay. All right, now what we can do is we can distribute this negative. And so I'm going to do that. I'm also going to kind of leave this alone. This part right here, I'm going to kind of leave alone. And the reason for that is I think things will cancel out and it'll be nicer or easier to do it algebraically later. And so if I were to do this, this is going to be my limit as delta x tends to 0. Now, if I do that, I get x minus delta x all over root x plus delta x times root x plus delta x all over delta x. On this, I invert and multiply So I'm going to invert and multiply, which means this is going to come up to the bottom. It's funny saying up to the bottom. But the limit as delta x tends to 0 of, and now x minus x goes away. So I have negative delta x all over delta x root x plus delta x times root x plus delta x. And if you can do multiples of these steps at once, you're more than welcome to. But I want to make sure that I get every single step that I'm supposed to get. And so root or delta x divided by delta x, those cancel. And now I get the limit as delta x tends to 0 of -1 over root x plus delta x times root x plus delta x. And now here's the part where I thought some of this might cancel out. As delta x tends to 0, that will go to 0. This will go to 0. And so I'll be left with equals. And now that I've taken the limit is no longer there, and this is -1. This is root x times root x plus root x, which is really -1 over root x times root x. This is root x times 2 roots of x, which is equal to, I have 1, 2, 3 roots of x. That means that I'm multiplying the things under the root. So that means I have 2 root x cubed, and that's a -1 over 2 root x cubed. This is our f prime. This is our derivative. I am going to rewrite this. Okay, so I'm going to rewrite this as f prime of x, and it's the power over the root. And so this is -1 over 2x to the 3/2. The reason I do this is in 2.2, when we start talking about the power rule for the derivative, you'll have to kind of switch it up like that in order to utilize that rule. The other reason is it's going to be a little bit easier, I think, to run our calculations. And so if I run back up to the top and find out what my slope was supposed to be, my slope was -1/2. And so this is also my slope, which means that f prime of x is equal to the slope, which means that -1/2 or -1 over 2 times x to the 3/2 is equal to our -1/2. Now, if I multiply both sides by -2, then the negatives cancel, and the 2's cancel on that side. The negative cancels here, and the 2's cancel, and so I get 1 over x to the 3/2 is equal to 1. That means that x to the 3/2 is equal to 1. Okay, and so if I multiply, or I have to multiply I want a 1 here. I really want x to the first. And so I got x to the 3/2. Let me neaten this up a little bit. I really want x to the first. In order to cancel fractions like that, like 3/2, I have to multiply it by 2/3. In order to multiply exponents, I have to raise them to a power. And so this is to the 2/3 power. And that equals 1 to the 2/3 power. 1 to any power is just 1. This cancels those. And now you're left with x equals 1. Okay. Now remember that our original function, f of x, was equal to 1 over the square root of x. And so y, in this case, if x is 1, then square root of 1, y is equal to 1 over the square root of 1, which is equal to 1 over 1, which is just 1. And so I have the point 1, 1. Now I have a point, I have a slope. There's my slope. My slope was that negative 1/2. So there's my point. My slope equals negative 1/2, right? Put those two things together, I get y minus 1 is equal to negative 1/2 times x minus 1. And there it is. There's our line tangent to 1 over root x, but it's also parallel to the line x plus 2y minus 6 equals 0. And that's how you do it.